Hello, my name is Naja Tao, and I have been doing a series of conversation starter questions. This question is from www.scienceofpeople.com. And the question is, does 1 plus 1 always equal 2? My answer, sometimes. Sometimes 1 plus 1 always equals 2. I'll give an example of that in a minute here, but just for a little bit of background on where I'm coming from, I really like math because I think it works your brain out in ways that it wouldn't exercise otherwise. I think that doing math increases your logical abilities. I think it increases your problem-solving abilities. And I think it increases your abilities in areas other than math, like writing. I say all this, though, as somebody who's always been a little bit slower in math. However, throughout my homeschool years in middle school and high school, I had a tutor who had a degree in physics, and biology and physics probably became my favorite classes. I really liked a lot of my classes in high school, but there's like something really special about biology and physics for me, and art. But I actually ended up switching my major in college to physics at one point. I've had a lot of different majors, but when I switched to physics, I'd considered myself not really a math person up to that point, but once I switched to physics, it was do math or die. Like, your hopes and dreams for switching to that major are gone if I can't do those math classes. And I did end up adapting and passing my classes. But I've always wanted to talk about some of the stuff that I think is weird about math, that bothers me and doesn't seem to bother a lot of other people. The main thing that trips me up are the assumptions that you're always having to make in math as intuitive leaps. Everything in math is a symbol. So going back to does 1 plus 1 equal 2, even with something super simple like 1 plus 1, what if 1 didn't represent the quantity of something? What if 1 represented on or off, like with Boolean algebra? In that case, 1 plus 1 would equal 1. I mean, with Boolean algebra, I don't think that they would represent the equation that way. But you could represent the equation that way and it would still have the same meaning. But it just seems to me a lot of the time like the symbols and operations in an equation could be any rule. We have to know the context. Sometimes you have to know the context in quite a bit of depth to understand the rules. So in the 1 plus 1 example, the Boolean algebra has a different set of rules than arithmetic. And when I go through a math textbook, I always feel like a lot goes left unsaid and unexplained. Like, why are we doing things this way? And why is there only one right answer when there are so many alternatives about what these symbols could mean? Aren't there so many different ways that this fact that's being presented to me could be true? Like, aren't there all kinds of different things I could do to make what you're saying true? So I would just sometimes be really confused about why everyone reading that math textbook would be expected to make the same assumptions. And most people would make the same assumptions. So I think there would just be some kind of element of logic that I just wouldn't see that other people were seeing when they would read a math textbook. And I decided to have a chat with Google Gemini about some of my issues with making this intuitive leap. And it had interesting things to say. And I mean, nowadays I really like to consult AI to get an overview of like the most common things that people are saying about a topic. I mean, a Google search just doesn't seem to cut it anymore. It doesn't seem as good. It doesn't seem to really prioritize the best information anymore like it used to seem to. So I just use the LLMs. Google Gemini said that the main problem I'm facing is that a math textbook presents math as a finished structure, but the student needs to recreate the mental imagery that led to that conclusion. And it said that there are some things you can do to try to recreate this imagery. Like you can ask what physical object or physical process the mathematical concept is modeling. You can ask what real-world quantity the variable represents. You can draw a picture of the concept. And I would lean very heavily on all of those things as a student learning about physics. Other things it suggested are going line by line through the text of the math book and breaking the theorems down into even plainer language. You can also test very simple cases. And you can ask what problem was unsolvable before that math was introduced. And, I have often looked for books or papers about the psychology of math or problem solving, but the materials are usually kind of expensive and there aren't a lot of them. Most of the materials I've seen are about business, and I think that's kind of ironic or interesting because you're not, with the business problem solving, you're not trying to play with these really black and white conceptual metaphors for relationships and rules and steps, like in, I guess what you call ordinary math, linear math. Instead, you're trying to predict the behavior of a complex adaptive system in business, which is more like it's nonlinear math, and that can get really complicated really fast, even for very powerful computers. Complex adaptive systems and chaos and nonlinearity are the reasons why your weather app is wrong so often, unless, the weather event is really big and it's like right on top of you. So I'm thinking these books about business probably don't really admit to the role of chance in business success. I kind of think that humanity would be better off studying the psychology of problem solving, something that's more predictable, like the math I was talking about before. I guess you would call it linear math. I'm assuming, because that's the opposite of nonlinear math. I really wish I knew more about that topic. I really wish I knew more about that topic. I was thinking of going to graduate school to study nonlinear dynamics some more, because I just find it to be a really interesting topic, and It's hard to teach yourself and to have the discipline yourself to learn that kind of stuff. And it's also really useful, I think, to have a certification in in STEM. But anyway, does 1 plus 1 always equal 2? It always depends on the ideas behind the symbols. So if you have anything to say about anything I've said in this video, or if you have an answer of your own for the question, does 1 plus 1 always equal 2? Please leave your answer in the comments. Please like and subscribe. And I'm going to color. Actually, no, what I'm going to do is I'm going to look up the opposite of nonlinear dynamics. What is the opposite? Whoa. Opposite of nonlinear dynamics. Let's get this figured out. It is linear dynamics. Okay. That's not really enough information for me. Predictability, non-emergent behavior. Proportionality. I'm not sure if all the math I was thinking of in this video would be linear dynamics. I mean, would geometry be linear dynamics? I guess it would be because it's proportional. It's the response of the system to multiple inputs is simply the sum of responses to each individual. I would say that in geometry. Predictability, I would say that's true in geometry. No emergence, and yeah, there's no emergence in geometry. So yeah, I was just thinking when I was thinking of math and problem solving, I'm thinking of stuff like algebra and geometry and calculus and the traditional path. I don't know much about upper level math. So, when I think of fall, I don't think of tea. Is that weird? I can kind of think of this because, I mean, don't they call this like mulled spiced tea or something? Isn't this like grog or something in Swedish? Grog, let me look that up. Grog, Swedish. Yeah. Glögg. Glögg. Swedish infused wine. That's what this looks like to me. It looks like Swedish infused wine. But I guess it could be spiced tea. So I guess if this is wine, I'd make it dark red. And if it's spiced tea, I'd make it kind of a brown. I'm gonna go with the brown because I just the thought of drinking spiced wine does not appeal to me. I don't like to drink. It'd be nice if this was a little more red. Guess the inside of an orange is kind of white, kind of yellow. What would be in the center? Is that a seed? Oh. A nice bright orange. A little brighter than these colors. the inside of a color, is the inside of an orange roughly the same color as the rind? I guess it kind of is. I mean, it's just shiny on the inside, but it's basically the same color. I tried to give something away on Craigslist today, and I've been trying to give it away for a while now. The ad's almost expired. And people they won't take it. They'll call me and they'll be like, yeah, I'm coming over at X and such a time. And they'll be like, oh, something came up. I'll contact you later about the thing you're giving away. And then they don't. But this time I actually had somebody show up to my house, and they just didn't like the thing when they got here, which surprised me a little bit because, it's a pretty high quality thing I'm giving away. I mean, if I were to sell it, I could probably make $100, a couple $100. But the object is just taking a lot of space. So I just kind of want to get rid of it. So I guess one person's trash is another person's trash. That's okay. I just wish that it didn't take up so much of my time waiting for people. I view this as a clear mug. What color would the bubbles be? I mean, I guess they're really the same color, aren't they? And then fall colors for the leaves. Maybe red. A little pop of red and some yellow and some green. I think fall is my favorite time of the year. It's not hot. It's not cold. Not that I mind the cold. I mind the snow. So in the fall, there's no snow. And you've got the holidays. So that, for me, the holiday season brings up a lot of nice nostalgia. I'm going to go in with the green. I feel like leaves in nature are a little more bright than that. Yeah, because I mean, just doing this activity reminds me of those turkeys that you would make in elementary school, where you'd stick your hand on a piece of paper and then you'd trace your hand, and then the fingers are the tail. I was really into the crafts that we would do in elementary school. I don't think, when I look back on that time, I don't think people loved the crafts the way I loved the crafts. The way I would really take the time to make exactly what I wanted um, for that assignment. I think I carried that on over into college, like not with crafts, of course, but with papers. Like it would really be important to me to find a topic that I would connect with when it would come to writing papers. Would that be brown? Would the other half of the leaves be brown? No. Yeah, that's nice. Yeah, I'd remember taking a lot more time than the other kids, like in third grade or first grade or whatever. And I would take a lot more time ordinarily to make sure the diorama or the Valentine's Day mailbox was just what I had been what I had been imagining it would turn out to be like. I don't know. I mean, I think if you didn't like doing crafts in elementary school, at least in my elementary school, I mean, maybe school is kind of miserable for you. But it's that way for me at work too. Um, had somebody ask me, why do you work so hard? And it's like, okay, well, that's flattering that you notice that I do work. I do put effort into things. But what else is there to do? There's nothing else to do at work but work, so I might as well work hard. I mean, do I want to just accomplish nothing with my day? No. I want to be able to look back on my day and think, hmm, yeah, I did that thing. I did that thing and it turned out well. Or, I did that thing and, there are a lot of things I could have done better. And at least you learned something. Yeah, I never know where I'm going with what I say when I'm coloring. It's just a different mindset than trying to organize my thoughts into something. Something logical and orderly that somebody would want to follow. Um, the coloring is just me hoping that I don't say anything embarrassing. Do. I had a flash of a thought that maybe these bubbles should be black, but then I'm like, black like pepper in an egg? Black like an empty space? Black like a polka dot? Why do I want that to be black? I don't know. So I just kind of dropped the idea of black. Make this plate colorful. Yeah. The background can be a nice, it's all right. It's a little too the same. Yeah. I like that. Yeah, I'm not really understanding some parts of this picture. Wondering if I should have left that white. There we go. There we go. Now, some of these hypothetical questions that I'm looking at on various websites, some of these hypothetical questions are getting harder. There's this college website of philosophical questions, and those questions are very hard, in my opinion. And I think there's a risk to making your questions too hard, just based on personal experience, because I used to like to write questions for my friends to answer in email surveys. If you make questions too hard, people will just completely ignore your survey. It's not like they have to answer your questions or take your survey most of the time. I mean, I guess they would be forced to answer your questions if it was for a college class or something. Or at least they'd be a lot more inclined to answer your questions. But something like a YouTube video where someone can click on or off at will. If you make the questions too hairy, people probably, I'm assuming, just aren't going to be interested. I like this. Okay, well, I'm going to end this video here. Thank you very much for watching, and I really hope that you'll join me for another video later. Bye.